and write this down if you would be so kind. The ratio of boys to girls in the class is what, 3 to 4? 3 to 4. If there are 12 girls, how many boys are there? When I say 12 girls, how many boys? And this, ladies and gentlemen, just like that whole container problem, you look in your math book and you see a whole bunch of words. Your first thought is, I need somehow to organize them words into some thoughtful mathematical sort of thing here. And if you see the word ratio, the first thing that's going to pop in your mind is to draw what I like to call a ratio box. Highlight, underline, star, and cloud around that because this is incredibly important. A ratio box. It's not complicated, not terribly exciting, but it is kind of exciting. And a ratio box is going to look like this. A ratio box is nothing more than kind of making organized equal fractions. So it looks like this. It's really usually just simply a box cut into 4 nice little quadrants, because it's 4. Okay? And what you have are, these are the labels. You've got your ratio, you've got your actual, and then over here you've got the two things that you're comparing. And in this problem, I happen to be comparing what? Boys to girls. So it doesn't matter which one I'm going to put boys on top here and girls in the second one there. It doesn't really matter which way it is as long as I keep my numbers clear. What is the ratio of boys to girls? It says right here the ratio of boys to girls is 3 to 4. 3 boys to 4 girls. Are you with me there? And then it gives me the actual number of girls. How many actual girls are there? 12. And I want to know how many boys there are. And that's relatively simple because it's 2 equal fractions. Here are your fractions. You have 3 over 4 equaling some number over 12. And that's something you don't need to show a lot of work for because it's simply what, Cameron? Huh? Yeah, because 4 times 3 is 12, so 3 times 3 is 9. Quite often, they stand and cheer at that, but not always. That's what I thought. What do you think about that, huh? Let me give you another one. Let me give you another one here. Write this down. The ratio of the length to the width of a rectangle. The ratio of the length to the width of a rectangle is, don't worry, I'll find it here, 5 to 4. Is 5 to 4. If the room is 20 feet long, if the room is 20 feet long, comma, how wide is it? Now I'm going to give you 30 seconds or less to draw me what you think the ratio box for that would look like. Give you a clue. It's done the same way the last problem is, just the labels are a little bit different. Ratio and actual on top stay the same. It's the two things you're comparing that change on the ratio box. Please make me weep, because remember there's like 30 seconds that I have to give you the same. So much of what you're going to say, how close we are to this. Everyone can say, yeah, right, way to label it like I asked. Way to label it. So far, homework is in your future, because I don't see many ratio boxes being labeled. Those I see are numbers. And numbers, while in themselves are good, labels in themselves are so much better. And they don't have to be long, elaborate, calligraphy writing, but just your standard letters that you know what you're comparing sort of things are. Do not ever draw a ratio box without labels. Your ratio box should look just like this. Some of you aren't real good at drawing boxes even when you have lines. And this would be all I need to see. Ratio, actual, length, width. Was my ratio of length to width is 5 to 4. What are the actual things there? 20 feet is how long it is, so the 20 goes here. And then you're asked to find out how wide it is. So 5 times 4 is 20. 4 times 4 would be 16. 16 feet long would be the thing. I repeat a need in the video, to see labels on these boxes. Do yourself a favor and show your work. Understood? Is that clear?